Welcome back. We are now looking at section 4.5c. In this part of 4.5, we are going to look how to solve logarithmic equations, which are a little bit complex than the ones we have seen before, and similarly the exponential equations a little bit tougher than the ones we have seen. Like the exponential function, the logarithmic function is also a one-to-one function. So both are one-to-one functions because they are inverses of each other, and so both of them have something called a one-to-one property, which we can use while solving the equations. If you recall, the exponential function, we had the one-to-one property written as if a to the x is equal to a to the y, then x is equal to y. Okay, and now in the same way we have a one-to-one property for logarithms, which says if log of x to the base a equals log of y to the base a, then the argument of the logs will be the same. So the log goes away. So we can, in other words, we can cancel the log and we get x is equal to y. But this cancelling is not a good idea, because what happens when students see something like what I have next, so they see log here, log here, log here, this is wrong. You cannot do that. That is not correct. This property means only one log term on the left and one log term on the right, and the bases must be the same, and there shouldn't be anything in front of the log, so nothing over here. Then only you can cancel. So now let's look at the examples. Another important thing before we start our examples is to remember is that when we are solving the logarithmic equation and we got to an answer, we must check that answer into by putting it in the original or the given equation. So we cannot not check, because some of the answers may not be the solution. So we must always check. Like if you recall in the radical equations, when we are solving radical equations, we always check the answer. Same thing here. So first example. So we have one log term on the left and we have two log terms on the right. So I'm going to keep them where they are, but trying to simplify, or like in simplify means if there is a thing in front of the log, I have to remove that. How will it get removed? It will go inside the log and become the power of the argument. So the left hand side will become log of x square. What do I do, or what can I do with the right hand side? Well, if you think, we might be able to apply the one-to-one property that we just saw, because we can combine these two terms and put them in one log term. So we get log of 2 times 3x minus 4, the product rule. Okay. So now once we have this situation, can you see this is what the one-to-one property says? So then this gives me that x squared equals 6x minus 8. What is that now? This is a quadratic equation, so we can should be able to solve by factoring. So we bring everything on one side and have the right hand side 0. Factor. So there we get x is equal to 2 or x is equal to 4. So these are our answers. Now we have checked them. So x is equal to 2 when you check, plug it always in the original equation. So I get 2 times log of 2 equals log of 2 plus log of, when you plug in 2 here, 2 times 3 is 6, so you get 6 minus 4. Here you have 2 log of 2. Well, we could move the 2 inside the log and make it power of the argument 2, but let's just keep it like this as it is and try to simplify the right hand side. But what is this? Log of 2 plus log of 2 is 2 log 2. Now since the right hand side is the same as the left hand side, we say yes, x is equal to is a solution. Same way you can show that x is equal to 4 is a solution. So 2 log 4 equals log of 2 plus, so what is on the right last term? Log of x, 3x minus 4. So what will I get here? So plus okay, let me check over here why there is not enough space there. So check x is equal to 4. So we have 2 log 4 equals log of 2 plus log of, so when you plug in 4, 3 times 4 is 12, minus 4, 8. Okay, so they are not looking same, so we have to go maybe one more step. We can bring this 2 inside, so it become log of 4 square, and here what can we do? Use the product rule. So 2 times 8, but now you get log of 16 equals log of 16, so you get the same answer, hence x is equal to 4 is also solution. So we say solution x is equal to 2, x is equal to 4. Box it. Okay, looking at the next example. Now this one is, you can say, somewhat similar to the one we did earlier. So this is with single log term. So what we do, we isolate the log term. So we subtract 3. See, we get log of x squared minus x minus 2 equals 2. So what do I do from here? We can convert it to, this is at base 2. So we can convert it to exponential form. So I say 2 raised to the power 2 equals x square minus x minus 2. Now 2 square is 4. So it means I will subtract 4 from both sides. End up getting 0. Now factor. So which gives me what is the next step? Check. So we check x is equal to 3. In the original equation, so 9 minus 3 minus 2, which is 9 minus 5, or you can directly say 4, and on the equal to 5. So we have 3 plus log base 2 of 4 equals 5, but what is log of 4 base 2? So log of 4 base 2 equals what? How do you need to think about it? there are two different ways. You can think of it as log base 2 of 2 squared, and then you see by the property or by the power rule, you can see this will be 2. So we get 3 plus 2 equals 5, which is correct. So x is equal to 3 will be a solution. The next we check is x is equal to negative 2. So plug in, so we get 3 plus log of 4 minus negative 2, so 4 plus 2 minus 2. So this gives me the same thing. So we are here. Hence we get the correct answer. So solution x is equal to 3 and x is equal to negative 2. Let us look at the next one. Okay, you know what, I will let you guys try this. So idea is, because there is a constant term here now, so bring this one on this side and move the constant term on the other side of the equation so that it looks like log base 9 of x minus 5 plus log base 9 of x plus 3 equals 1. So you guys try, and then we will see. I'll come back in the next video and see how you did that.